Number system, 9th standard. Operations on real numbers. First statement, the sum or difference of a rational number and an irrational number is irrational. Whether it is sum or difference. Let us take a rational number here first. Rational number 2 plus root 2. This is a irrational number. And even now 2 minus root 2, this is also a irrational number. Whether it is sum or a difference, both are irrational numbers. The second point, the product or quotient of a non-zero rational number with an irrational number is irrational. That is, here we will take 2 into root 2. This is also irrational. Root 2 by 2. This is also irrational. You can take 2 by root 2. That's right. 2 by root 2 is also irrational. 3 by root 5. This is also irrational. Here the quotient is there. That's right. All these are irrational numbers. Here one is rational and another one is irrational. That's right. If we take like this means all these are irrational numbers. You will get the product is here. You can take another product too. 3 root 3. 5 root 2. Likewise. 7 root 7. Whatever it is, the product of a rational number and an irrational number is a irrational number. And the quotient of a rational and an irrational number is definitely a irrational number. Whether it is there in the numerator or in the denominator, you need not worry about that one. Whether the irrational number is there in the numerator or the denominator in the first case and the second case, whatever it is, that will be a irrational number. Third statement, if we add, subtract, multiply or divide two irrationals, the result may be rational or irrational. When both are irrationals, and on that when we make an operation, addition, subtraction, multiplication or division, anyone, that's right, the result may be rational or irrational. Here there is a difference, but in all these two cases we got only the irrational numbers. When one is rational and another one is irrational, definitely it will be a irrational number. That's right. But when both are irrationals, there is a chance of getting a rational or an irrational number. Example, root 2 into root 2 is equal to 2. And even root 5 by root 5 is equal to 1. Both are rational numbers. Is right? But here, root 3 by root 5, this is irrational. Is irrational. Is right? There is, this continues like this. We can't expect that it will be rational or irrational likewise. That's right. Exercise 1.5. Classify the following numbers as rational or irrational. Here, first one is 2 minus root 5. Here, root 5 is there. So, it is irrational. Number. This is equal to, let us simplify, 3 plus root 23 minus root 23. So root 23, root 23 cancels, which is equals to 3. This is a rational number. Next one, this let us simplify this one. So what happens here? It is of the form 2 by 7. Root 7 cancels, so 2 by 7 remains. It is in the form of p by q, so it is a rational number. This is an irrational number. irrational number. This one pi is a irrational number. The product of the irrational and the rational is irrational. Second main, simplify each of the following expressions. First question, 3 plus root 3 into 2 plus root 3. First, it is of the form binomial into binomial multiplication. So, what is the procedure what we will follow in the two binomial multiplications? Likewise, only we will do here also. First term 3 into 2 plus root 2 plus root 3 into 2 plus root 2. That's right. 3 2s are 6 plus 3 into this one. Root 2 is 3 root 2 plus root 3 into 2 is 2 root 3 plus here root 3 root 2. 6 plus 3 root 2 plus 2 root 3 plus square root of 3 2s are 6. As see both the roots are same. Square root of 3 square root of 2 is there, so we can multiply it. If not, it is not possible. This completes this multiplication. 3 plus root 3 into 3 minus root 3. This is also how means the same way. 3 minus root 3 plus root 3 into 3 minus root 3. So 3 into 3 is 9 minus 3 root 3 plus 3 into root 3 minus root 3 into root 3, that is root 3 into root 3. Here 9, here minus 3 root 3 plus 3 root 3. These two cancels. So here minus root 3 into root 3 is 3. So the answer is 6. This completes this problem. Root 5 plus root 2 whole square. It is of the form a plus b whole square is equal to a square plus 2ab plus b square, where a is equal to root 5 and b is equal to root 2. So let us substitute these values. Root 5 plus root 2 whole square is equal to a is root 5 whole square plus 2 into root 5 into root 2 plus root 2 whole square. So what happens here? Root 5 whole square is 5 plus 2 into root 5 into root 2 means as the root is same, 5 2s are 10. Yes, right? Plus the here root and square cancels. This one is equal to 2. So 5 plus 2 is 10 plus 2 root 10. This completes this problem. Even you can take common 2. So what happens? 5 plus root 10. This completes. You have made a mistake here. Here 5 plus 2 is equal to 7 plus 2 root 10. This is the answer. Root 5 minus root 2 into root 5 plus root 2. So this is also of the form a minus b into a plus b is equal to a square minus b square. So what happens here? Root 5 minus root 2, where a is equal to root 5 and b is equal to root 2. So into root 5 plus root 2 is equal to, where a is equal to root 5 whole square minus root 2 whole square. So what happens here? 5, your root and square cancels, minus 2. Here also square root and root 2 cancels. So 5 minus 2 is equal to 3. This is your answer. Recall, pi is defined as the ratio of the circumference, say C, of a diameter of a circle to its diameter, say D. What is that is pi is equal to C by D. This seems to contradict the fact that pi is irrational. How will you resolve this contradiction? There is no contradiction. Remember that when you measure a length with a scale or any other device, you only get an approximate rational value. That is, till date, we have not measured any irrational numbers. Length of a line in an irrational, and we have not given the length in an irrational number. So you may not realize that either C or D is irrational, even though they both are irrational numbers. We can't measure, we have never measured that one in an irrational number. So there is no contradiction. Represent square root of 9.3 on the number line. First, what we have to do here is, firstly I will be drawing a straight line, and I will be marking a point here, A. This point be A. And now what I will do means I will mark a, as I want 9.3, square root of 9.3, I will adjust my compass to 9.3. Yes, it is there, 9.3. So I will mark here a point 9.3. And then afterwards, this one is 9.3, 3 units. Okay, now, and then afterwards, I will take another 1 unit. Another 1 unit here. From here to here, I will take 1 unit. And A to B, this one is B, and here to here 1 unit, this one is C. Now what I will do means, I will take my compass and divide. I will find the midpoint of AC. Yes. I will join these two lines, so I will get a midpoint. This point and this point. If I join, means I got a midpoint. Let this point be O, the midpoint. And then afterwards, with this midpoint, with the help of this midpoint, I will making OC as, taking OC as the radius. I will draw a semicircle. I will draw a semicircle. Yes, right? And then afterwards, at B, I will draw a perpendicular. With the help of the protractor, you draw a line here, measure an angle 90 degree and draw a line. This will be equal to the, this length of this line will be equal to the square root of 9.3. Square root of 9.3. So this length is square root of 9.3. This completes. As we have to represent B, and let this point be D. BD is the length root 9.3. So what we have to do means, we have to represent this and the number line. We will adjust this length with the with the compass and take the length. Yes, right? And then, yes, this point is this point, let us take this B is as 0 and this one is 1, and likewise, so means here this point represents 9.3. The point here represent, if we take this as 0 and this one C point, this one is 0, this point is 1, likewise, so means 9.3. This point represent 9.3. 9 square root of 9.3 is nearly equal to 3. We are getting here 3. Yes, right? 3.04, likewise it will be there. So it is nearly equal. Yes, we have done the exact. We have marked here exact square root of 9.3. Fifth main, rationalize the denominator. First problem, 1 by root 7. So for 1 by root 7, what we will do means multiply and divide with root 7. So here what happens? This one, 1 into root 7 is root 7. Root 7 into root 7 is 7. This completes the problem. So the denominator is no more a irrational number, it is a rational number. Let me move on to the second problem, that is 1 by root 7 minus root 6. So how to solve this one means 1 by root 7 minus root 6. So we will be multiplying this with root 7 plus root 6 by root 7 plus root 6. So what happens here? Root 7 plus root 6, 1 into root 7 plus root 6 is this much, and what we got here, a minus b into a plus b is there. So which is of the form, this is of the form we want, let us understand, a minus b into a plus b. So we will write a square minus b square. Likewise, root 7 whole square minus root 6 whole square. What happens here? Next step is root 7 plus root 6. Here square root and square cancels. Here to square root and square cancels. So what happens here? 7 minus 6. So what is your answer? Root 7 plus root 6 by 1. So it is simply root 7 plus root 6. This is the denominator as is no more a irrational number. Let us move on to the next problem. That is third one. 1 by root 5 plus root 2. As there is plus root 2 is there, we will be taking minus root 2. Here we should multiply with root 5 minus root 2. Root 5 minus root 2. The same we will take, and we will take here minus. So root 5 minus root 2 when divided by, this is also of the formula like this only, a minus b into a plus b is equal to a square minus b square. So root 5 square minus root 2 square. Here square and root 2 cancels. Square and root 2 cancels. So root 5 minus root 2 by 5 minus 2. So here root 5 minus root 2 by 3. This completes this problem. And the last problem is fourth one. So 1 by root 7 minus 2. So here what happens here? 1 by root 7 minus 2 into root 7 plus 2 by root 7 plus 2. If there is plus, you should take here minus. Here minus was there, we have taken plus. Likewise here also minus was there, here plus. The same with the sign change. Yes, right. So root 7 plus 2 by, here same formula, a minus b into a plus b is equal to a square minus b square. So here square minus 2, you should not forget to put here square. Yes, for this also you should put mark a square. Root 7 plus 2 by, here square and root cancels, 7 minus 2 square is 4. So what happens here? Root 7 plus 2 by 7 minus 4 is 3. This completes this one.